This is Mrs. Palmer-Quay with the first video for Module 11. In this video I want to talk about solutions and also suspensions and colloids. A solution is a homogeneous mixture. It's a mixture where we can't separate out the parts. And it consists of a solute, something that is dissolved, and it's dissolved in a solvent. That's the substance that it's being dissolved into. So when we talk about solutions, we use the words solute and solvent. Both solutes and solvents can be solids, liquids, or gases. It doesn't have to be a solid solute dissolved into a liquid solvent. And so just to give you some examples here, in the atmosphere, in the air, we have a gas dissolved in a gas. So both the solvent and the solute are gases. They're in the same state of matter, the same phase. But the water in the air, giving it the humidity that we all know so well here in South Carolina, is a liquid dissolved in a gas. When you have smoke from a fire, you then are having little bits of a solid in a gas, little actual tiny pieces of ash or soot. In our carbonated beverages, we have carbon dioxide gas dissolved in the liquid of the beverage. Many common household products, such as vinegar, are actually a mixture of liquids. You can have, of course, salt or sugar dissolved in water if you make your own Kool-Aid, so that's a solid in a liquid. Although you probably haven't experienced it in your ordinary day, there are some circumstances where gases can be dissolved over a metal. There are liquids dissolved in a solid solvent in all of your teeth fillings. And you also can have a solid dissolved in a solid for the alloys for two metals such as bronze or brass, where they are actually, the metals are combined and make something new. But most of the time when we're talking about solutions, we're talking about aqueous solutions, and water is the solvent. So most of the solutions we'll be handling in our chemistry labs will be aqueous solutions. Remember, water is a highly polar molecule, and so it dissolves ionic compounds and other polar molecules. Because of those partial charges, partial negative charge on the oxygen end and a partial positive charge on the hydrogen end, then it can pull other charged particles to it, and that solute can just sort of slide in and be dissolved in the water. Water is actually known as the universal solvent because it dissolves so many different things. It's very, very important for biochemical processes in living organisms and also in the geological processes of erosion and weathering that make the world the way it is. Dissolving is all about attraction. A solute will dissolve in a particular solvent when it is more attracted to the molecules of the solvent. Here I said water molecules since we do the aqueous solution so often in lab. But the solute is more attracted to the water molecules than it is to itself. The attraction to water is more overpowering than the ionic bonds that will hold an ionic compound together, or the intermolecular bonds that are happening in between covalent molecules. We use the phrase like dissolves like as a way of just sort of a shorthand of noticing this, that things that are polar will dissolve in other polar molecules, and it really depends on this level of attraction. The illustration on the bottom tries to show what happens when this attraction between the water and the ions found in sodium chloride actually causes it to dissolve. So here you can see a chloride ion that has been pulled out of this solid crystal of salt. A sodium ion has been pulled apart. This sodium chloride has been pulled apart. Each of those ions is now surrounded by water molecules. And so the attraction between the ions and the water is greater than the attraction that the sodium and chloride had to each other. So they're just pulled away. They really can't do anything about it. When ionic compounds dissolve, these ions then separate. They're pulled apart, and the big word we use for that is dissociate. So they dissociate into their individual ions. This illustration again of how salt dissolves in water just reinforces the fact that you have from every sodium and chloride, one sodium and one chloride ion. So you actually get two particles. In contrast, when covalent compounds dissolve, they don't dissociate. So that here, our example of sugar on the right, each one of these little hexagons represents a sugar molecule, and it doesn't break apart into any of its component parts. It just comes off the major crystal, but the actual sugar compound, say this is table sugar, so that C12H22O11 molecule is going to stay intact. The number of particles that come about when a substance dissolves will become more important in a couple weeks when we talk about how freezing points and boiling points change in solutions as compared to pure water. But for right now, I just wanted to introduce the idea that ionic compounds will divide into multiple particles, but covalent compounds will not. And we call that dissociation. Just a word about dissolving solid solutes. If you want to dissolve things more quickly, want to increase the rate of dissolving, the rules are to crush the substance, stir the substance, or heat it up. When you crush something, you are making it in smaller pieces and you're actually increasing the surface area, so there are more edges of the particles to react with the solvent, and those little ions can be pulled off from many, many surfaces and more quickly go into solution. Of course, when you stir it up, you are encouraging the molecules of the solvent and the solute to crash into each other. Chemical reactions always happen when molecules, or only happen when molecules can touch. So by stirring, you're increasing the interaction by just helping them bang into each other. And then adding heat, increasing the temperature for solid solutes going into liquids, generally also increases the temperature or increases the rate of dissolving because it's increasing the kinetic energy, that speed of bouncing around that the molecules are doing. And so again, you have a greater rate of reaction because molecules are interacting more frequently. I wanted to talk about two other things that kind of look like solutions but are not, but are very, very common, especially the colloids. Suspensions and colloids are both heterogeneous mixtures, so you don't have the same concentration of particles in any one part of it. The homogeneous mixtures, remember, they're the same all the way through. Heterogeneous mixtures, a spoonful here will be slightly different than a spoonful there. If it is a suspension, it will eventually experience a settling out of some of the particles in that mixture. And we call that settling out stuff a precipitate. So it'll fall to the bottom. And I have a glass of muddy water over here, and you can see that it's darker in the bottom. We've got some particles precipitating there, settling out, falling out of the liquid and just going to collect on the bottom. Colloids, in contrast, do not settle out, but they will disperse light, which is, we call it the Tyndall effect. And so in these pictures here on the bottom, we have a solution on the right. You can see where the light is coming in and going out through this beaker, but it's not present. You don't see it in the solution in between. But in this colloid solution over here, you can very clearly see this beam of light going right through the middle. The light is bouncing off the particles as it passes through the colloid, and so it is dispersing it. We can see it. The difference between solutions, colloids, and suspensions oftentimes is on the particle size, that the particles are larger in both of these two situations than they are in solutions. The particles in solutions are so small that they do not precipitate out or they do not bounce light rays, but those in colloids and also in suspensions will. Colloids are really common. A lot of our household products are colloids, so they're not solutions, but they're still a mixture of things. So for example, some of the specific words that we use to describe them are given here in this chart. And you can see when we have a solid dispersed in a glass like smoke, that it's an aerosol. When you have a foam dispersed in a solid, a gas in a solid, you have something like a marshmallow. Or if you have a liquid or gas dispersed in a liquid, you have our whipped cream. An emulsion is when two liquids are combined that normally would not mix, but there's a third substance that holds them together, such mayonnaise. For example, mayonnaise is made out of vinegar and oil, and it is the egg yolk that is part of mayonnaise that helps hold them together. The egg yolk is the emulsifying agent. You also can have solid emulsions where a solid is dispersed through a liquid, things like butter where you're having solid fat in a very small amount of liquid, but there is a little bit of liquid in there for the butter. And then a sol or a gel, that's the other word we use to describe this, is when you have a solid dispersed in a liquid, and a lot of our substances such as paint or jello gelatin are actually this kind of colloid. So colloids are probably something that you didn't realize that you were interacting with, but they are something that's very common in our food and in our household products, in the things that we are seeing all around us. So that covers our introduction to solutions, and this free information on suspensions and colloids. We'll go on to some more specific information on solubility in the next video.